Hello, I'm Susan May from the Charles A. Dana Center and would like to share with you some information about the Dana Center Agile Mind Common Core Algebra 2 course program. The Algebra 2 course program builds on students' work with linear and quadratic functions and equations in Algebra 1 and extends this work to different types of functions and problems involving those functions. The Common Core State Standards content standards make an explicit connection between functions, equations, and modeling. Take a moment to read the slide, which is a quote from the Common Core State Standards Algebra Conceptual Category Introduction. Our Algebra 2 course design is based on the ideas presented in this paragraph. Our work with each function type follows this general trajectory. First, we study key characteristics of a function type. Then, we analyze different representations of the function and make connections among them to understand how they reveal information about the function. Next, we use the functions to model problem situations. And finally, we ask questions about the problem situation that give rise to equations built from the function model. And we solve those equations to answer the question. In addition to modeling with functions, the Common Core State Standards work with statistics also takes a modeling focus. The statistics work in our Algebra 2 course builds on students' work in Algebra 1 with statistical modeling. The standards for mathematical practice guide the process that is used to meet the mathematics in the content standards. These process standards are embedded throughout our Algebra 2 course program. Students should be making sense of problems and persevere in solving them, reason abstractly and quantitatively, construct viable arguments and critique the reasoning of others, model with mathematics, use appropriate tools strategically, attend to precision, look for and make use of structure, look for and express regularity in repeated reasoning. Our CCSS Algebra 2 course was designed to embody the intent and content of these standards. The Dana Center Agile Mind Algebra 2 course consistently provides students with connections to prior learning as well as connections within the course. Our goal is for students to build on their understanding of simpler functions and algebraic processes as they work with increasingly complex function types and processes. In doing this, we have the opportunity to embed just-in-time review of content that will be necessary for new learning. You can see this design principle as you look at the first 4 topics in the course. We begin with sequences and series to revisit ideas from Algebra 1 related to linear and exponential functions. This topic makes a strong connection between arithmetic and geometric sequences and related functions and provides an opportunity to review function notation as well. Topics 2 and 3 introduce students to concepts such as inverses and transformations that are applicable to various function types. The early topics provide a general context for these concepts so that students may begin to develop a big picture understanding of their future work with functions. Students will revisit these concepts throughout the course in more detail and at a deeper level as they study various function types. In Topic 4, we again work to connect to prior learning by building new functions based on functions that students know from Algebra 1. Namely, by multiplying or dividing linear and quadratic functions, we open the door for students to develop their understanding of polynomial and rational functions. The next cluster of topics, topics 5 through 8, present an in-depth study of polynomial and rational functions, as well as the equations that arise from problem situations involving these types of functions. Notice, as recommended by the CCSS, the connection between functions and equations is inherent in the course design. Students study the function type and then solve equations involving the function type. These topics represent a balance between seeing the structure in polynomial and rational expressions and modeling with these functions to solve problems, as described by the Standards for Mathematical Practice. Students experience using equivalent forms of expression to reveal information about the graph or the problem situation being modeled. The next several topics in the course continue to expand students' knowledge of function types, including square root, exponential, and logarithmic functions. In each case, the functions are explored and then the equations and inequalities, where appropriate, are solved. Students connect to their understanding of inverses to generate new function types, such as square root and logarithmic functions. Students also apply their general knowledge of transformations to use these functions to model problem situations. Students follow their initial experiences with revisit ideas from probability, which were covered in the grade 7 standards. Throughout these topics, students apply probability to real-world contexts and make sense of problems. Students also extend their work with statistical studies. This set of topics ends with students taking a deeper look at different aspects of data collection and experimental design. Students move back to functional models with a study of sinusoidal models. Again, the connections to transformations of functions is made in this topic and extended as students add a new idea around periodicity. Once students have filled their library of functions, they have the opportunity to model problem situations and make decisions about which function model would best represent a situation. Students have to support their decision about the model and can critique the reasoning of peers as they discuss various models. The bulk of the last 3 topics in the course address content that may go beyond core content defined by your standards. We include these topics for teachers and students who may choose to engage in a deeper study of these ideas, or for a district who may choose to include these concepts in an Algebra 2 course. In Topic 21, students study matrices as a tool for solving systems of equations. The standards for mathematical practice are again tightly woven into this topic as students model situations, use matrices as algebraic models, and look for structure. Topics 22 and 23 look towards relations that are not functions. Conic sections are explored first from a geometric perspective and then from an algebraic one. Now let's take a look in more detail at a topic. Each topic begins with an overview which launches the concepts to be studied in the topic, often in a contextual setting, and engages students in the concept. Following the overview are explorings. These provide opportunities for in-depth learning of new ideas. The summary gives the key learning outcomes. Each topic also has 4 types of assessment that can either be used as formative assessments during the topic or as a topic-level summative assessment. Each topic is also supported by advice for instruction for the teacher to use in preparing and planning for teacher. Our goal is always to keep the teacher at the center of instruction and provide the teacher with high-quality tools to create a rich and engaging learning experience for students. The advice for instruction provides teachers with classroom strategies that elevate the teacher's practice and help the teacher connect the mathematics with the mathematical practices and processes that students should be developing. So let's take a look at this topic, polynomial functions. This topic builds on previous work with linear, quadratic, and cubic functions in the previous topic to help students make sense of the behavior they see in the larger family of polynomial functions. In the first exploring, students analyze the key features of the graphs of polynomial functions. Students attend to precision of language in the way that they describe the graph of a function. During the classroom instruction, students record their thinking and learning on activity sheets. They review prerequisite skills and have the opportunities to reinforce their thinking. The activity sheet also provides additional practice problems to reinforce student learning. In the second exploring, students take an in-depth look at the end behavior and zeros of polynomial functions. Again, language and notation are introduced to students as they communicate about functions. Students interact with animations to quickly explore different polynomial functions and then make conjectures about the number of real zeros. In the third exploring, students look at more complex polynomial functions, up to 6th degree polynomials. They test their thinking about functions up to degree 3 on higher degree polynomials. As they engage with the animations, they must develop viable arguments to justify their conjectures and critique the reasoning of their peers. These activities allow students to look for structure in the polynomial expressions that define the functions. Students also apply their reasoning to create functions with given conditions, such as the number of real zeros. Students connect their reasoning about zeros to the number of extreme values. Once students have studied the structure and the graphs of polynomial functions, they consider problems involving polynomial functions and real-world phenomena that can be modeled by polynomial functions. Students choose appropriate models for situations based on how quantities in that situation vary, with particular emphasis on the short-term and end-term behavior. This topic shows the importance of using structure of algebraic expressions to understand functional models. Our hope is that this program will be a powerful resource for teachers that supports their implementation of the standards and supports students in their learning. In the topic we looked at, you saw the emphasis on the content standards and practice standards. The Algebra 2 course program provides teachers with a state-of-the-art tool to create an engaging learning environment for students where they can explore algebraic structure and use functions to model problem situations and solve equations that arise from questions about the situation. These experiences provide opportunities for students to collaborate and communicate about mathematics and use mathematics to model their world. Thank you for your time, and I hope you continue to explore the Dana Center Agile Mind course programs.